In this problem, we have an organ pipe closed at one end and tell us the fundamental frequency is 220 hertz. And they ask for the length of the pipe and the frequencies of the first three harmonics. So because this is closed at one end, if you look on page 12, they talk about how to know whether it's an example of two free ends or two fixed ends or one fixed end and one free end. So in this case, we find on page 12 that we have the case of one fixed end and one free end. So we need to use equation Q12 or 1.12b. And so that says that the frequency is equal to v over 4L, where velocity is the velocity of the sound of a sound wave, and L is the length of our organ pipe, times n, the frequencies of the harmonics. So in this case, our frequency or our n values are 1, 3, and 5, so they're odd numbers. So we know for the first harmonic, the fundamental frequency is 220 hertz. So what we want to do is we want to find the length of the pipe. That's the first thing. So we know for n equals to 1, when n equals 1, I know that my frequency 1 is equal to 220 hertz. So I have F is equal to V over 4L. And if I multiply both sides by L, then I get, and then I divide both sides by F, I get L is equal to V over 4F. And when I plug in, the speed that I'm going to use here is the speed of sound, so that's 343 meters per second over 4 times the frequency, which is 220 hertz, and hertz is 1 over seconds. So I can see here that my seconds are going to cancel out. I have 1 over seconds on the top and 1 over seconds on the bottom. So I'm going to have, when I multiply this out, I get 0.39, and my units are in meters. So that's my the length of my pipe. And now for the harmonics, the way I want to do that is I know if I look at this equation here, F1 just means that I have V over 4L times 1. And I know that F1 is equal to 220 hertz. So F3, that would be my next harmonic, that would just mean that this would be equal to 3. So it really means I'm multiplying my first harmonic by 3. So F3 is going to equal 3 times 220 hertz, which is equal to 660 hertz. And the next harmonic is going to be F5, and so that's, again, just going to be 5 times 220 hertz. And so that means that's going to be 1,100 hertz. So I have it says, what are the frequencies of the first three harmonics? I guess we'll say this is the fundamental, so we'll do F7 down here. So F7 is equal to 7 times 220 hertz, which is, let's see, 1,400 plus 140, so 1,540 hertz. And that's it.